All right. So fourth hour. Today we are going to get into um, our inequalities in standard form. So it says, how is graphing an inequality that is not in the context different from graphing an inequality that is in context? So that's our focus for today. So it says, when you're modeling an inequality that is a result of a real-world scenario, it's easy to understand why shading happens above or below the line. So scenarios could involve a budget, so on and so forth. So you can read that. But when there's no context, where do you decide to shade? So we didn't get to this. So JJ's Bakery. So basically, JJ owns a bakery and is planning to make a weekly batch of pies and cookies. One pie requires two cups of flour for the crust. One batch of cookies requires 3.5 cups of flour. And he had 28 cups of flour in the pantry, wanted to use it all. So this was the equation, okay? So it says, how are we going to use this symbol and the shading related to the story? Well, again, because, number one, because this is in a solid, this is a equal to, a less than or equal to, it's a solid line. Because it's equal to, it includes the points on the line. And then it is shaded below the line because the inequality is less than. So again, when it's greater than, we go above the line. I'm just going to kind of mess with this pen here and see if it'll let me change the thickness of the pen. That's the line. It used to let me change the thickness last year. This thing writes so thick. Okay, so now they're going to ask us a question. So is the combination 10 pies and 2 batches of cookies in the solution region? Okay, well, and then it says, how do you know? So if you take the equation, all right, so 2 times 10 is 20. 3.5 times 2 is 7. So you get 27 is less than or equal to 28. So that is a solution because 27 is less than 28. It'll fit in that region. Okay, this statement here is true, so it's a solution. If this statement was not true, if it said 29 is less than or equal to 28, it would not be a solution in the as a possibility. So now it says convert standard form equation into slope-intercept form. So again, we've had some little bit of practice doing this, so we have to get this into y equals mx plus b. Okay, so the first thing we got to do is take the 2x and move it over here. So again, anytime we move something across the equal sign or the inequality, we do its opposite. So we would subtract 2x to both sides. And I'm left with 3.5y is less than or equal to negative 2x plus 28. Now we got to divide both sides by 3.5. This is where things are going to get a little weird here. So I'm going to use a calculator to kind of get it. So that goes to 0. All right, and if I take my calculator, negative 2 divided by 3.5, I get 0.5714, and I'm going to take that answer and turn it into a fraction, which is negative 4/7 x. And then 28 divided by 3.5 is 8. So this would be our equation in slope-intercept form. This and that are the same thing. Okay, the same thing. All right, let's move on to the next page. So it says the graph of x is minus 2y is less than 10 is shown at the right. Okay, notice that it is a dotted line. All right. In all of the examples, every time the less than symbol was used, the shading was below the line. In this case, and again, it's a little difficult here to see, but you can kind of see the little gray up here. The shading is up here. Okay, it's a little bit different coloration. Okay, you can see it from there. In this case, the shading is above the line. Why? And this answer is because it says when the inequality is converted to slope intercept form, the inequality sign will flip. All right. Now, I'm going to show you that in just a second here when we convert it right here. So the line is dashed because the line here, the inequality, after school and I can't spell. That's why I don't teach ELA. The inequality doesn't include equal to. So that's just a less than. So that's why it's a dashed line. So if we go to convert this, watch what happens when we convert this. So I got to move the x over. That goes away, and I'm left with minus 2y is less than negative x plus 10. Now, when I divide everything by negative 2, all right, that becomes 1. But again, when I divide anything across an inequality that's negative, the inequality has to flip. And I'm left with positive 1/2 x, okay, minus 5. So now when you graph, there's your minus 5 right down here, that point, and you go up 1 and over 2, there's your second point. So when you make your line, it's dotted. Now, when you plug in a point, you can test it. And you can see that it's shaded above the line. I always like to use the point, especially on a graph, as 0, 0. It's super easy, right? If I plug in a 0 for y and a 0 for x, I get 0 is greater than negative 5. Okay? Is this a true statement? Yes, 0 is greater than negative 5. So since 0 is above the line, that's where you see it shaded. If it's false, you'd shade below the line. And that's an easy way to test. All right? So it says, convert the following to slope-intercept form and explain why the graph matches the inequality. So I got to move the x over by adding it to both sides. And I get 2y is less than or equal to x plus 6. The inequality doesn't flip because I didn't divide or multiply. Only when you divide or multiply will it flip. Divide everything by 2. And y is going to be less than or equal to 1/2 x plus 3. So again, when you graph this, there's your 3. Up 1 and over 2 is right there. So there's our line. It's solid because of the equal to sign, less than or equal to. And we're shaded below because, again, it is less than. But again, if you test the point 0, 0, which is in the shaded region, plug a 0 in for y and a 0 in for x, I get 0 is less than or equal to 3. Okay, that is a true statement. So that means we shade in here. where that 0, 0 point is. And all these points would make it true. All right? Let's work on the next one. Oh, sorry. There's a little part down here. So is the point negative 2, 2 a point in the solution? All right. So let me erase the shading here because you can kind of see the shading. So I want to. All right. So negative 2, 2 is right there. Is that a solution? Yes, because it's on the line. And since it's equal to, okay, it's on the line, it can count as a solution. So yes, it's on the line of a less than or equal to inequality. If it was just less than, that would not be a solution. So let's do the next one. Move the negative x across by adding it. I get negative y equals is less than x plus 5. And now to get y positive, we're going to divide everything by negative 1. So when we do that, this becomes y. The sign flips, and we're left with negative x minus 5. So again, here is minus 5. I go down 1 and over 1. There's my second point. So that's how you see the line. The line is dotted because there's no equal to in the inequality. Okay? And again, why do we shade above? Well, if I plug 0, 0 in for here, there's 0, 0, right? So if that's right, that region would be shaded where it's at. Well, you plug a 0 in for y, a 0 in for x. Is 0 greater than negative 5? Yes, it is. So that's why you see that area in here shaded. All right. So is the point negative 4, negative 1 a solution to the region? Well, if I get a negative 4, 1, 2, 4, down 1, that's actually on the line. Okay. This would be no because the line is dashed. Which means it's not equal to. So anything on that line would not be a point. Okay? So let's say if we tested, we did something and the point was over here, yes, that would be a solution. But since that point is on the line, it is not. Okay? So to summarize, how do you graph an inequality in standard form that is not in context? Well, you want to convert to slope-intercept form. And then you want to, once you do that, you're going to graph the y-intercept and the slope. Okay? Once you graph those 2 points, you will then determine if the line is solid, which again, these are the 2 scenarios where it would be solid, or dotted. And again, these will be the 2 scenarios where they're dotted. All right? Once you do that, then you got to follow the rules for shading. And again, sometimes I told you, you can pick, if it's not on the line, pick the point 0, 0. That's always an easiest one to test. I call it the test point. So you always kind of know where to shade. And don't forget, if the coefficient, this is kind of an important one, so we'll start this one. If the coefficient in, oops, not from, in front of y is negative, the inequality will flip. All right, and then we'll have some practice on this eventually. So that was the notes. So I'm going to stop the video here. Hope this was helpful.